we've talked about functions, and we basically have said that functions are equations, and that when you've got values that you want to put in to the equation, you can get the corresponding output, and then you can have points and you can graph the points. Now, because we're dealing with equations, we will also be dealing with formulas. A formula is a way of finding something using the steps mathematically that they tell me to use to find a value. Now, an arithmetic sequence is actually a sequence that you will see very often in all sorts of different assessments, such as the SAT, the PSAT, any sorts of SSAT testing, or any of those things. And what an arithmetic sequence is saying is the following. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate, which is called a common difference. That's a lot of words. That's a lot of words for basically saying something like the following. If I gave you a pattern, such as 2, 4, 6, 8, 10, 12, you know that it is increasing at the constant rate of adding 2. If I gave you a pattern, -1, 0, 1, 2, 3, ... you know that that is a numerical pattern that is increasing at a common rate of adding 1 to the previous in order to get to the next one. So I could ask you, what's the next number in the sequence? And all you have to do is go, oh, if you're adding 1 to all of them, you're going to add 1, and it's going to be 4. That is an arithmetic sequence. It is a list of numbers that have a pattern, and you can figure out the next number down the line by just adding what they call the common difference. Now, if I was to give you another arithmetic sequence, such as this, and I asked you, first of all, if I stated this is an arithmetic sequence, then you would know that there is what they call a common difference. A common difference does not always have to be added. It could also be subtracted. Can you tell me what the common difference of this pattern is? Well, from there to there, from -8 to -16, you subtracted 8. And from -16 to -24, you subtracted 8. That is called the common difference. The common difference is that you subtracted 8. If I asked you, can you tell me what the next number down the line is? What would you say? -32, because you're going to minus 8. What if I said, what is the 12th number down the line? What would you have to do?
Keep going.
You would have to either keep going, or you would have to find a formula that finds it for you. If I said, what is the 75th number? That means you've got to look at it and go 1, 2, 3. Oh my gosh, I have to go 72 more numbers down the line. That's going to take a really long time. Well, the mathematicians discovered that there is a formula. Because there's a mathematical pattern, they discovered that there is a formula to be able to find any number of term down the line if it is an arithmetic sequence. And that formula is this guy you see right here. So, first of all, a sequence is a list of numbers that form a pattern. Each number is a term. So if we were to go back to this list, each of these numbers, 3, 5, 7, 9, 11, those are terms. Those are terms. This is the first term. This is the second term. What's the fifth term? 11, right? 1, 2, 3, 4, 5. If I look at this here, what is the fourth term? 21. And the common difference is that you minused 4. So, going back to that crazy formula, what they use is the following. And you're going to get used to seeing these kinds of formulas throughout algebra, throughout geometry, throughout Algebra 2, because they are shortcut ways of finding numerical stuff. In this case, what this is saying is the following. The nth term, n is the number of term. So if I ask you, what is the 75th term? N is 75. So n is the number of term, like the term number. The nth term of an arithmetic sequence is equal to a sub 1, which means the first term, plus however many n is, minus 1 times d. That's, again, lots of algebra that I'm going to explain to you because I don't want you to just memorize, I want you to understand. Is this an arithmetic sequence? Yes. You know it's an arithmetic sequence because it's a series of numbers and it's continuously changing at the same rate. What is that rate?
1.
1. You're adding 1, correct? If you were to look at this term right here, which is the third term, and I asked you to write an equation, a formula, on how I found the third term, you would look at it and go, well, the third term is 6. How did I get to 6? Well, what's the first thing I would have to look at? What the first term was. I need to know who my first term was. And it's 4. That's the first term. That's where that A1 means. So the reason that they're using this A1 here is because every term relates to the first term you started with. I know 6 occurs because something was added to the term right before him. Who is the term right before 6? That's where the n minus 1 comes in. The term that you're looking at, 6, that term was created by taking your original term, which was 4, your original term was 4, and adding whatever the term you are in, the third term, minus 1 times the common difference. So they created this formula that you see up here so that you wouldn't have to recreate it every time. And now let's put it to use. First of all, is this an arithmetic sequence?
Yeah.
Well, how could you tell?
It's minus 0.2.
It is continuously going down by the same rate. That same rate is considered the common difference. It is the common difference. I'm reducing it by 0.2. So yes, it is an arithmetic sequence, which was all that they were asking for in this specific question. Is this an arithmetic sequence?
No. Right.
Remember that the definition of an arithmetic sequence is that it has a common difference. That means that you are adding or subtracting, not multiplying or dividing. From here to here, you multiplied by 1/3. Same thing from here to here. But multiplying by 1/3 is actually what they call a geometric sequence because you're multiplying. You're not adding or subtracting. So no, this is not an arithmetic sequence because you're not adding or subtracting. You're multiplying. Now let's look at this guy. This is where all that equation comes in. They give me the arithmetic sequence 36, 39, 42, and 45, ... And they say to me, hey, find the next 3 terms down the road. Well, I could very easily, because finding 3 terms is not that big of a deal. It's not like it's telling me what's the 110th term. It's just asking me what are the next 3 numbers. That's pretty easy to do without the formula, right? Do you see? The common difference is that I am adding 3 from each previous one. Remember, common difference, you're adding 3. It could be adding or subtracting. So the next 3 down the road are going to be 48, because I added 3. Add 3 more, and I get 51. add 3 more, and I get 54. I didn't have to use that fancy formula because it's just the next 3 down the road, and it's really easy to just do. So you don't have to use the formula for this one. If, however, they ask you something like this, if I'm asking you to find the 25th term, granted, yeah, you could, if you wanted to, write down all 25 terms, but that would take you a really long time. This is where they say, okay, you are going to use that formula that the mathematicians came up with so that you don't have to write it all down. You just have to know what each part represents. They want to know what the 25th term is. That means they want to know what is a sub 25. What is the 25th term? We know that in order to get this, I have to take the first term, because that's what A1 is. A1 represents the first term. What's the first term? 2. Yes? So A1 is the first term, 2, plus n minus 1. N is the number of terms that you want. So in this case, it's 25. 25 minus 1 multiplied by the common difference. What's the common difference? You are minusing 4. So D is negative 4. So times negative 4. You literally plug it into the formula, and then you just do your work. Well, order of operations says you have to do what's in parentheses. That's 24. Then you have to multiply by negative 4, and then you add 2. So that's going to give me 2, and then 24 times negative 4 is negative. So this here is negative 96. 2 minus 96 is negative 94. That means that if I was to list all of the numbers down the road, the 25th one would be negative 94.
Do you write like 25 equals?
So what you would write, that's a great question, you would say A sub 25, because that's telling you that in an arithmetic sequence, number 25, the 25th number, is equal to negative 94. Let's look at a real-world application of this crazy arithmetic sequence. It says the odometer on a car, okay, so that's like the thing on the car that tells you how many miles you have, reads $60,473 on day 1. Every day the car is driven 54 miles. If this pattern continues, what is the odometer going to read on day 28? Well, I could take the really long way, and I could say, well, if the first day, day 1, which we would call A1, day 1 is 60,473. You know that every day, what are you adding to this number? You're adding 54. So that means that day 1, if you had a whole bunch of different days lined up, you would add 54, then you would add 54 to the next one, and so on. That would take a really long time to get to 28 days. And so what you do is you actually physically plug it into the formula. You know day 1 is 60,473. That's A1. What is 54 going to be? What is he referred to as?
Original adding
The number that you keep adding. That's called the common difference. The common difference is 54. And they want to know, what is it going to be on day 28? What is 28? The number of items. That will be n. N is equal to 28. So, again, A1 is the very first day, the very first number. The D is the 54 because that is what you're continuously adding consistently. And the 28 is the N because it's the number of items that you want. Day 1, day 2, day 3. Okay, day 1 was 60,473. Day 2 is going to be 54 more than that. Day 3 is going to be 54 more than this guy. Day 4 is going to be 54 more than day 3. Day 5 is going to be 54 more than day 4, and so on. And because of that, we get that the first term is this. The common difference is 54 because that's what you're continuously adding. And N, they want to know what is day 28, the 28th item. Can anybody recall that formula that we just had?
A1
A1.
equals A2.
So A sub N is equal to A1 plus N
minus 1.
minus D. Sorry, N minus 1. Sorry, yes, N minus 1 times D. Okay? So the 28th item, A28, is going to equal 60,473 plus 28 minus 1, which is 27, times the common difference of 54. And on your calculators, what is 27 times 54?
What is 47 times 54?
1,458.
And now add that to 6473.
1,458.
Wait, what?
1,400.
61,931.
So I know that on the 28th day, my odometer is going to read 61,931. Yeah, so this formula actually comes from the fact that you're doing the 54 multiplied by 27, N minus 1, 28 minus 1 is 27, because there's 27 more numbers coming after this guy.
The original.
So, plus the original that you started with. That's exactly where that formula comes from. So there's no need to memorize that formula if you know, well, if I want to know what the 78th day is, that means I'm going to add 77 times, whatever the difference is, to the original. And that's where this comes from. So that is the number of the odometer reading on the 28th day. All right, so what you all are going to be doing for your assignment tonight is you're going to complete the independent practice, which basically is asking you if it is an arithmetic sequence, yes or no. And remember that in order to tell if it's an arithmetic sequence, it has to have a common difference. You have to be adding or subtracting something to the previous one that is constant. If you're multiplying or dividing, that's not an arithmetic sequence. That's what you will learn in geometry is a geometric sequence. And then you're going to find, for numbers 3, 4, and 5, the next 3 terms down the road, which means you need to know what it's changing by. And then it's going to ask you for numbers 6 through 9 to find the number of terms. So here it's asking you what is the 17th term. So that means you know that your first term is 5, n is 17. You have to figure out the common difference, and you either have to rationalize how you would get that answer, or you would use your formula which says a of n, in other words, your nth term, is going to be your first term plus n minus 1 multiplied by d.